In this video, I'll be demonstrating how to extract clean-burning hydrogen gas from a common acid available at most hardware stores. A balloon filled with hydrogen can lift approximately 10% more weight than the same size balloon filled with helium. The only reason why hydrogen is not used in place of helium when filling balloons is because it is so flammable in the presence of oxygen. In order to create the setup used in this video, we will need a 1 liter heat-resistant flask, a rubber stopper to fit that flask, 1.5 feet of 3/8 inch vinyl tubing, a 2 liter bottle, 1 foot of 1/4 inch vinyl tubing, and a strong epoxy. The flask and stopper may need to be ordered online, but the rest of the parts can be easily picked up at any hardware store. The first step will be to take the 2 liter bottle and drill a hole close to the bottom the same diameter as the 3/8 inch vinyl tubing. Now is also a convenient time to drill the same size hole through the rubber stopper for the flask. Epoxy or a water-resistant glue is used to permanently affix the 3/8 inch vinyl tubing into the hole in the side of the bottle that we have just created. The rubber stopper remains on the other end of this tubing. A hole is now drilled through the bottle cap to fit the smaller 1/4 inch tubing. The end of this tubing is then inserted and is likewise epoxied into place. With these steps complete, what we now have is a setup where hydrogen gas can be produced in the flask on the left. As the gas is produced, it is directed through the 3/8 inch vinyl tubing into the bottom of the 2 liter bottle, which is filled with water. Bubbling the hydrogen through water cleans the gas and removes impurities and acid vapor that would otherwise be present without this step. Once through the water, the clean hydrogen is then fed into the 1/4 inch vinyl tubing, and from there can be filled into balloons or any other container it is to be held in. The reaction shown in this video uses a strong acid, and so it is very important to be wearing chemically resistant gloves and shielded safety glasses at all times. It is also very important to be using a true heat-resistant flask when used in this process, as other forms of glassware will shatter when undergoing the heat produced. First, moving outdoors to begin this reaction, we will start by filling the 2 liter bottle 3/4 of the way full with cold water. Another 300 milliliters of water is added to the bottom of the flask. Muriatic acid is the common name for hydrochloric acid, which will be the primary reactant in this process. This sort of acid can be purchased at almost any hardware store for only about $5 a gallon. 300 milliliters of muriatic acid is carefully measured and then slowly poured into the flask to mix with the water that we previously added. The hydrochloric acid molecule contains 1 atom of chlorine and 1 of hydrogen. The hydrogen atom can be released by reacting the acid with aluminum. The most convenient source of aluminum for this reaction is aluminum foil, which should be cut into a 6 inch by 6 inch square sheet. This section of foil should then be balled up and carefully dropped into the flask of acid. The stopper on the flask should be quickly replaced, and the aluminum should begin to react within about 30 seconds. The aluminum reacts with the acid, producing hydrogen gas and leaving behind aluminum chloride in the solution. Once the reaction slows to a stop, the stopper on the flask can be removed and another section of aluminum foil dropped in. This process can be repeated until a reaction no longer occurs. In the 300 milliliters of acid that have been added to the flask, there is enough hydrogen to fill about a 30-gallon trash bag. To demonstrate hydrogen's lifting properties, I will be attempting to lift this remote-controlled car off the ground. This weighs about 200 grams. Thin trash bags end up being a lightweight and inexpensive option when searching for a large container to fill with hydrogen for lifting objects. In this case, I have filled them completely with hydrogen and used a plastic zip tie to seal them shut. With 3 bags attached, the vehicle feels completely weightless, and on the 4th it takes off skyward. After going through several hours of work to make enough hydrogen to lift this car, I know there's nothing more that you all want to see than for me to just set it all on fire. Well, I find it incredibly amazing that we're able to float solid objects off into the sky with nothing more than chemicals from a hardware store. I won't deny you an explosion any longer. It turns out that the burning hydrogen is not quite enough to penetrate the nearby bags, so it looks like we get a few more tries at this. Thanks for watching, and be sure to check out Drive on YouTube for performance automotive videos. You can click this banner for more.